Hello and welcome back to 30 Days of AWS Terraform. My name is Piyush and this is day 19 in the series. And till now, we have covered a great lot of stuff. And give yourself a pat on the back if you have been following me in this journey from day zero. Till now, we have completed a lots of concepts and a few mini projects, and I believe a couple of real-time projects as well. In this video, we'll be looking into another concept. You can treat this as a mini project or you can convert this into a mini project, and we'll be discussing Terraform Provisioners in this video. So I hope you have been consistently doing the practice, doing the hands-on and completing the task even in task.md files of each of the repository of each of the folder. And I hope you have been learning consistently so far. So thank you for that. And thank you for supporting the channel. And thank you for publishing your progress on LinkedIn, Twitter, and so on. So without any further ado, let's start with the video. So in this video, we'll be looking into, as I've told you, Terraform Provisioners. Okay, let me just make a small change. I need to exit the Docker desktop. It's adding some load on my system. Okay, yeah, hopefully it should be better now. Okay, so what are the provisioners in Terraform, right? So there are three type of provisioners in Terraform. Now, what is provisioner? Provisioner is something that performs a task. Okay, this task could be as simple as running a file, executing a file. Like let's say I'll just add it over here, executing a script, or something like running a command, or doing some operation, right? Some sort of operation. So that's the main purpose of provisioner in Terraform. Now, there are different things that you need to understand when working with provisioners. There are three type of provisioners, each suitable for different use cases. Okay, so the first one is over here, which is local exec. Local exec is used when you want to execute some script, some command locally for some purpose, right? So this is like in your local terminal where your Terraform host resides, right? Where you have installed your Terraform, you will run those commands over here. For example, in this series, like what I have shown you in the demo so far, I'm running Terraform commands locally from my MacBook, right? So for me, the local exec will be running on locally on my machine. Okay, and I will show you examples as well. So basically, execute the system time, running few commands locally on the machine. It's like local exec. That's how it works. Now there is remote exec. As the name suggests, it will help you execute the commands remotely on a machine. Okay, so that's why the name remote execution. And because we are running the commands remotely over a machine or a server or a cloud virtual machine, this has to be over the SSH connection. So that means you would need the SSH connection details for it, like your key pair, public private key pair, and so on, and the authentication authorization for that, right? So remote exec is something that you would run over SSH remotely over a machine. So this could be running like a copy command remotely, or installing. I'll just add it over here. So let's say installing Nginx on a machine as a bootstrap, or when your servers are starting, at the initial first step, installing Nginx, or running apt-get update, and so on, right? So anything that you run remotely over a machine is remote exec. And the last one is file. Okay, so file provisioner is when you have to copy a file. So let's say this is the file. Let me change the color. So when you have to copy a file from locally or from one machine to another machine, right? So that's when you would use remote exec. Again, for this as well, you would need a SSH connection, and like you would need the key pair as well for this and this. For local exec, you don't need a key pair because it's running locally, right? So this is what a provisioner is, and this is why we use provisioners. And now we'll be doing the demo of these provisioners in depth, like how do we do that. So let's go back. This is my VS Code. Okay, So day 19 folder, again check out the code from the git repo, and I will walk you through. I'll add the code for provisioner, and I have some basic code written over here. So that's the provider block over here, and we have a data source because we need to get the AMI details, right? So we are getting AWS AMI for Ubuntu from the data source, right? We have added the filter as well. Now we have created one security group which allows ingress from all the IPs on port 22, so that I can just SSH into the server, egress to all the IPs for the outbound access. Now I'll be creating a AWS instance. So AMI details is we are getting from the data source, then instance type we are getting from a variable, key name we are getting from the variable, and group ID like VPC security group ID we are getting from the AWS security group dot ID. So this is the AWS security group, we are getting the ID from here. Now these are the tags. Okay, and here's the connection string, because I've told you, right? If we are using, okay, sorry, this is the connection string for EC2 instance, right? Type is SSH, user is var.ssh, private key, and host. So now there is a keyword self which we have not used earlier, right? So self is for this resource, right? So let's say we want to add the host details. So host details of this host, this resource. So we can access the private key or public key or whatever resources using self keyword over here. Type is SSH and user is SSH user, like it's from the variable, and will be providing the private key in a file. Okay, and file path will be providing in the variable. So if you can check the variables, right? So there is an instance type which is T3 micro, key name will pass it from the command line, then private key path will pass it from the command line, SSH user is Ubuntu. Okay, now let's go back over here. So this is the connection details, and that's the basic connection string for AWS instance, right? So now what we'll do is I'm inside the same folder. Okay, so we'll start with creating a key pair. Okay, so I'm gonna go over here and I'm gonna execute the CLI command. So AWS EC2 create key pair name is Terraform demo key, and the same key will be passing in the variable file, right? And query key material output text is, this is the file name. Okay, and then we are just providing permissions to that file. Okay, next it says key pair already exists. That's fine. If it's already exists, then we don't have to do, or maybe I'll just delete it. Yeah, for the sake of simplicity, let's just delete it. AWS. Okay, and key pair you will get in the EC2 section, and don't get confused with this key pair with the IAM keys, right? Because this key is specifically for EC2 instance, which will be finding over here, right? So I'll just delete it from here. Delete. Okay, and let's execute the command again. It says permission denied. That's okay. Maybe this does not have certain permissions, so I'll just use the sudo chmod 400. This is the permission that it needs. Okay, I'll just add the password and that's done. Okay, now it will have, oh, I think it has a sufficient permission 400. So read, write, execute. So 421, yeah, it has a sufficient permission. It's fine. We don't need to worry about it. Okay, now the key has been added. Let's do a Terraform init over here. I'm not sure if alias is set, so I'm just gonna set the alias. So tf init, initialize the backend. Okay, and blah blah. Let's do a tf plan now. Okay, it's asking me the key value pair. So let's do one thing, because we have not added that key value pair somewhere in the variable. We'll pass it from the command line. Okay, So let's just directly run terraform apply and hyphen var. If you remember in the environment variables and variables when we have discussed, I've told you like this is also a way you can pass the variables directly at the runtime. Okay. So hyphen var is equal to name, which is key name, is equal to terraform demo key. Okay. And go to the next line. The next variable is private key path, okay, equal to dot terraform demo key dot pem. Okay, so this is how we'll apply. It says var, maybe, yeah, there's a spelling mistake, so let's correct it. Okay, now it says must already exist in the chosen region. EC2 key pair terraform demo key. Let's check the name if it's the correct name. Oh, I did create that. Maybe it was not created. Okay, let's remove that file terraform demo key. Okay, and let's run that command again to generate the key pair. Okay, it shouldn't take that long, but let's see. Yeah, it's created now. Okay, and this command is also completed. Now let's run terraform apply again. Name of the existing key value pair, the name already exists. So let's check if the variable name is correct or not. Oh yeah, there is a different, right? So you see what it expect is key underscore name, and what we are giving is key hyphen name. So that's the difference. And you can check it from here somewhere. Var.ssh user key path. Here you see var.key underscore name, key underscore name. Okay, so let's update the command one more time, and I'll replace the hyphen with underscore. This should work now. Okay, enter a value, yes, and it will create the security group as well as the EC2 instance. So that is our basic infrastructure done, but we have not covered the provisioners yet. So that's what we are going to do. It's done now. It has been created. This is the instance ID, and this is the public ID of the instance, public IP of the instance. Now what we'll do, we'll create some more resources over here, and this time the resources will be of type provisioners, right? So first is we're gonna start with a local provisioner. So the way we do that is provisioner keyword and then the type of the provisioner. So let's start with local exec, and the same format over here. It says the provisioner is not expected over here. Maybe it goes inside. Yeah, provisioner goes inside the instance, right? Okay, now we need to add, like, what we need to do is with it, right? So it has a field called command. So we need to add the command over here. Let's say a Unix command. So I'm gonna do echo local exec created instance. Okay, and let's add the instance ID. So I'm gonna do the string interpolation again. And how do I get the instance ID? Because now I'm running this local executioner or local executor on the AWS instance, right? It's already there in the machine. So I can just directly use self.id, okay, for the instance ID. And with IP, now I can just add the IP over here. IP is your public IP. So again, self dot public IP. Okay, so this command will be executed as locally inside the local provisioner, right? So save this and let's run the Terraform apply again. Okay, it says no changes because we have not done anything yet, but this echo will be done on the machine itself, so you will not see it over here, right? So it did not make any changes because there were no changes. Like it's a different thing, like provisioner or local exec. It's not the update to the infrastructure, so Terraform will not make any change, right? So to reinforce the recreation of resource, we can use a command called terraform taint. Terraform taint, what it does, let me clear the screen. Terraform taint says that the resource has been degraded or resource has been broken and just recreate it. Okay. So I'm just gonna taint the resource. Resource name is AWS instance dot demo, I guess. Yeah, AWS instance dot demo. I'll just taint this and I'm gonna apply the changes again. It has been marked as tainted. So now it should force the recreation of instance, and now we should see some provisioner execution. Okay, hit yes. It will destroy and then it will recreate the resource. So let me just pause the recording for short time. Okay, so the resource apply has been completed. So one added, one destroyed. That means it destroyed the existing resource and then created a new resource. Here are the output. Now, if you will see over here inside the resource creation, you will see a local executioner as well. Do you see that in the output? So it says executing shell with this command and echo local executioner create instance. This is the instance ID with IP. So it has executed this command on the virtual machine itself. Now this is not a remote execution because we have provided the local exec inside the provisioner block. We were already inside that. So it's not a remote execution, it's a local execution, right? So now the next is will work with remote executioner and then the file executioner. So you can call it remote exec executioner or provisioner. Provisioner is the right term, but because the name says local exec or remote exec, it kind of like executioners, right? So doesn't matter what name you call it, but provisioner should be the right word. Okay. So now the remote executioner, remote exec, let's just call it remote exec. Okay, the way it will work is let's say you have to run some commands remotely on the machine. Okay, now what you will do is you will add, let's say, a provisioner block over here. Okay, and this time you will call it remote exec, and now you can just provide the inline script or whatever you want to run remotely. So I'm gonna use inline, and let's, oops, not the absolute function, inline, and then let's run sudo apt-get update -y, and let's run echo hello from, oops, not double single quote, hello from remote exec, and I'm gonna add this to a temporary file. Okay, so sudo t temp remote exec.txt. Okay, so it will create a temporary file, and I'm gonna close it over here. Okay, so multiple commands, so it has to be separated by comma because I'm just using the inline commands, right? So now it should create a file remotely on the machine with the hello from remote exec this content, right? So let's hit save and let's run the Terraform apply again, or let's taint the resource again and then apply. Okay, and then apply the changes again. Now once this is done, you should see this file created in the remote machine. Now with this, the file was not created, it just took the metadata and then it executes the command locally, right? So there is the difference between a local and remote executioner. Okay, I just said it again, remote exec. So let's wait for it to destroy and recreate the resource. Okay, now that it has been completed, let's log into the instance and see if that file is created or not. Okay, let's go to EC2 dashboard instances. This is the instance that's been created. Let's connect. Okay, the file should be there in the temp directory, so that's what I'm gonna do. Okay, oops, cd/temp. Okay, the file is here, remote-exec.txt. If I do cat on this, oops, cat remote-exec.txt, it says hello from remote-exe. This is what we already added inside our Terraform script, right? So this is how remote-exec work. Now the last one, which is file provisioner. So file provisioners, let's copy a file from the local machine to the remote machine. Okay, so for that we'll use a file provisioner. So again, provisioner, yeah, file pro. Okay, okay, provisioner is file. Now what we need to provide inside that, we need to provide like over here it was inline or command, right? But over here we need to provide source and destination. So the source file and the destination file. So source is the local file. So let's say from the same directory, which is module.path. This is how we access the current directory. No, actually path.module. Okay, and inside that there'll be a scripts folder. Inside scripts there is a welcome.sh file, and let's put that inside double quotes. Okay, so that's source, and destination will be the destination inside the remote directory, right? So /temp/ welcome.sh. You can give it the same name, and you can, or you can give it different name, doesn't matter, right? It's like we have to just provide the absolute path of it. So now what you can do is, after this you can create another remote executioner which will execute this file as well. You can do that if you want, but for now we're just copying the file, right? So let's taint this again, and I'm gonna execute this one more time. Terraform apply, yes. So currently if you go and see, there is no welcome.sh over here. So if I do that, there is no welcome.sh dot here. Now this instance will be recreated, so IP might change. This will not be the same instance once it is destroyed and once it is recreated. So we'll log into the new instance again once it is created. So let me just pause the recording again. Okay, it has completed now. Let's go and check the instance. Is it the same instance? No, it's froze now. Let's go back. A new instance might have been created, so let's hit refresh. Okay, this one, and hit connect, and now there should be two files inside the temp directory. One is welcome.sh, another one is remote-exec.sh. So cd temp, oops, clear. Come on. Okay, now we have welcome.sh and we have remote-exec.sh, and you can check the content. So this is simple script that will create another file, and then it will add some metadata like uname -a and the welcome message, whatever, right? So you can test this out yourself. You can check, and there'll be task in the GitHub repository as always, so you can try executing that and you can do the submission, but make sure you destroy the resources as well. Otherwise this EC2 instance will keep on running and keep accumulating the bill, which I don't want you to do. All right. Thank you so much. Share the video and the playlist among your friends, colleagues, whoever can take advantage of this learning thing. And if you haven't subscribed the channel, please do so and support it. Thank you, and I will see you tomorrow with the next video. Happy learning.